my dear students. Today's lesson is an important lesson in mechanics. It's about work and energy. How are work and energy used in mechanics? The terms work and energy are used in everyday life, but what do they mean? In everyday life, a student who has been studying hard for 2 hours would say that they have been doing work, as would a gardener who has been working in a garden or an athlete who has been training. Each of these people has spent time doing an activity and has used energy. In the process, the energy comes from food that people have eaten. The gardener and the athlete have used energy to create movement, and the student have used energy to create brain power. Energy comes in many forms and can be changed from one form to another, and this issue we will discuss it. In this chapter, we will show that when a force moves a body, it does work and causes a change in the kinetic energy of the body. We need to speak about the weightlifter. The weightlifter does work in lifting a weight because a force acts like the tension in the arm of the weightlifter to cause motion. The weight is raised vertically. However, no mechanical work is done when the weightlifter holds the weight stationary above their head because there is no motion, so no work done. But it needs a lot of effort to just stopping the weight from falling. We'll start considering the work done by force acting in the direction of motion. Work done in the direction of motion. For example, pushing a horizontal force, pushing a box by a horizontal force across the horizontal floor. If the force is doubled, then the work is doubled. But if the force is constant and the distance is doubled, also the work is doubled. Because simply, as we can see on the board, work equals force multiplied by distance. The work is measured in joule, and the force is measured in newtons, and the distance is measured in meters. So, what is the definition of 1 joule? 1 joule is the amount of work done by a force of 1 newton in moving an object a distance of 1 meter. As we can see the boat in the sea, and this boat is moving just in contact with the side of a channel. And there is a pulling force which is not parallel to the side of the channel. This is not the force causing the work. The force that causes the work is this one I'll draw now for you. This is the component of it, which is in the direction of motion. So we'll learn that the force causing motion and causing work is the one in the direction of motion. As we can see a tiny little red arrow down, which is the contact force. It's perpendicular, as usual, we know it from previous chapters. The perpendicular force to the surface does not cause work. Why? Because it's perpendicular to the motion. The one which causes motion is this highlighted one. It is the component of the inclined force. Let's take some examples. Here's a boy uses a constant force of 250 newtons to push a box 4 meters across a floor. Find the work done by the force. W equals Fd. W equals Fd. Work equals Fd. Work equals Fd. So now let's calculate it. 250 Newton, this is the force. 4 meters, This is the distance, and we need to find the work. So W equals FD. We'll just multiply 250, multiply by 4, and the answer will be 1000 joules. Another example. A girl holds a mass of 20 kilograms above the head. Find the work done by the girl. She's holding like the weightlifter. We just said this example before. The weightlifter just carrying a heavy load and just preventing it from falling down. How much is the work done? 0. Why? Because it's constant, it's just stationary, and he didn't move it. So does this girl. She holds the mass of 20 kilograms above her head. How much the work done? 0. Because the mass does not move. The third one. A ball of mass 0.05 kilograms falls a distance of 1.5 meters. Find the work done by the weight. 0.05 kilograms, it falls distance of 1.5 meters. You know, dears, weight of an object is usually referred as the work done by gravity. The weight of an object is usually referred as the work done by gravity. So now, if the mass is 0.05 kilograms, this is the mass, but this is not the weight. Okay? So you have to find the weight, which is the force, which is measured in newtons. W equals mg. You just multiply the mass by the gravitational acceleration. In Cambridge, it is 10 meters per second squared. In Edexcel, it is 9.8. So this mass is 0.05 kilograms. You multiply it by 10. So the answer is 0.5 Newton. It falls at a distance 1.5 meter. You have to understand something, because this particle is falling vertically, and the distance is the weight is in the direction of motion, so it does work. So now work done equals W equals FD. W equals FD. We'll just multiply F by the distance, which is 0.5 newtons, multiplied by the distance 1.5 meters. It will be 0.75 joules. Remember, we are dealing with SI units. SI units, we said before, it is the MKS system. M means meter, K means kilogram, and S means seconds. And this is to get force in Newton and to get work in joule. Now we'll take an example of moving a box. You will move the box from this point to that point. This is the start and this is the end. So this is the distance moved from the center of mass of the box, from the beginning of the trip till its end. But the problem is we are pulling it with an inclined force F. So F is not acting completely to get the work. You have to find the component of force in the direction of motion. So we have to resolve this force into two components. One of them parallel to the direction of motion, and the other one is perpendicular to the direction of motion. Where is the direction of motion? Here it is. The component which is parallel, it is F, parallel to the surface, parallel to the direction of motion. It is F cosine theta. And the perpendicular component is F sine theta, which does no work. The component that does the work is F cosine theta. That's why we have to adjust the formula. Yes, W equals Fd if the force is in the direction of motion, but if the force is inclined, so it is F cosine theta into D. So Fd cosine theta, Fd cosine theta, Fd cosine theta. What is the title? It is work. Work measured in joules. Work equals Fd cosine theta, Fd cosine theta. Say it a lot. Then let's have an example. A small truck is pulled 5 meters along a railway track by a force of 100 newtons at an angle of 60 degrees to the track. Find the work done by the force. Let's underline every information and write the symbol above it. 5 meters, it is the distance along a railway by a force 100 Newton, but it is not along, it's acting at an angle 60 degrees. So this is theta, and this is the force F. Find what? Find the work done. Let's recite the rule. W equals Fd cosine theta, Fd cosine theta. Force is how much? 100 newtons. Distance is in meter? Yes, no conversion. Multiply by 5. Multiply by cosine 60. Remember that cosine 60 is half. By coincidence, it is half. It means that you will not take the full force. You are taking half of it only. So after multiplication, you will get to 150 joules. We need to mention something, that there is a force that opposes the direction of motion. Then the work done by this force will be negative, and we will say that work done is against the force. There is something else I should mention, that work is a scalar quantity. Work is a scalar quantity. It has no direction. Now next, we'll have here an example. A ball of mass 0.05 kilograms is raised through a distance of 1.5 meters. Find the work done against gravity. The word against here, we are using it. Here is the mass. It's raised. Distance 1.5 meters. Find the work done against gravity. Simply we will find the weight. W equals mg. So you'll multiply the weight by 10, which is the gravitational acceleration, and the answer will be 0.5 Newton. This is the weight. So work done by the weight, work done by the weight equals Fd. So it will be force, which is 0.5, in the distance which is negative 1.5. So the answer will be negative 0.75 joule. This is work done by the weight. But if you want to say the sentence, which is work done against the weight, it will be negative the work done by the weight. Okay, so it will be 0.75 joule. This is the difference between the two sentences. Work done by the weight, it is negative, and work done against the weight, it is positive. Because it is work done against gravity. Okay, work done against gravity. Sometimes several forces are acting on a body, like the one in this example. Let's read it. Here we have a box of mass 5 kilograms. It's pushed up a slope, inclined at 30 degrees to the horizontal by a force 30 newtons, at an angle 10 degrees to the slope. The frictional force acting on the box is 2 newtons. Of course, motion up, then friction down. Say motion up, then friction down. The box moves a distance 3 meters up the slope. First of all, we have to understand that writing the direction of motion is essential. Okay? The first question, find the work done against friction. The work done against friction is this pink force, which is friction, which is 2 Newton. So part A, the answer is 2 multiplied by 3, it is 6 joules. This is work done against friction. Next question. Find the work done against gravity. Against gravity, of course, he's speaking about the weight, but the weight is not acting as full weight. It's only a component of it. So we have to find the perpendicular component and the parallel component. If this is 30, not 30, 30. So this component is W cosine 30, which is not doing work, but W sine 30 is doing work.